Hello everyone, this is Fahim Ahmed from Elevare, and today we'll be solving all of the mechanisms that you need from Edexcel AS Chemistry. This will cover the mechanisms from both Unit 1 and 2, and a lot of you have been requesting for this video, so without wasting any more time, let's just try to solve this down. Okay, so first of all, even before starting the mechanism, we basically need to know about some terms. So let's just first of all fix that terms, okay? So first of all, what you have to know about is a species, what we refer to as a nucleophile. Nucleophile. Now, what basically are these? In short, you could say that they are basically nucleus seeking. Nucleus seeking. And they could basically donate a lone pair of electron. They could basically donate a lone pair of electron. Donate a lone pair of electron. A lone pair. A lone pair of electron. Okay, and on the other hand, there is this another substance known as electrophile. Electrophile. Okay, and this basically is what I refer to as electron seeking. Okay, now this electron seeking and this nucleus seeking is crude terms. Okay, but I'll be using this for the simplicity of the overall process. This is what I refer to as nucleus seeking. Okay, and they could basically accept a pair of electrons. They could accept a pair of electrons. They could accept a pair of electrons. Accept accept a pair of electrons. Accept a pair of accept a pair of electrons. Okay, now what do I even mean by this? Nucleophile, nucleus seeking. Electrophile, electron seeking. This thing could donate a pair of electron. On the other hand, this thing can accept a pair of electron. Now what do I mean by this? We are basically gonna look in depth of this later in the video. Okay, but basically these are the two terms that you should be aware of. Okay, so let's start with the first mechanism from our syllabus, and that basically is free radical substitution. Okay, so whenever an alkane reacts with a halogen, it basically leads to the formation of a compound, and the name of the compound is what we refer to as haloalkane. Okay, and one of the essential condition for this reaction is UV light. UV light. Okay, so this basically is the first step of the reaction. So in this question it says that hexane reacts with bromine in the presence of ultraviolet radiation. In the presence of ultraviolet radiation, UV light, as I said, to form a mixture of haloalkanes. Okay, this is what I refer to as bromoalkane. If chlorine reacted with an alkane, it would lead to the formation of chloroalkane, and so on. Draw the initiation step of the reaction. So it basically is the first step of the reaction. Okay, so what basically would happen over here is that you have your bromine and you have your another bromine. Okay, this bromine and bromine is bonded together by covalent bond, which means that this bromine would be giving one electron and this bromine would be giving another electron. Okay, now what happens in this initiation step is that in the presence of UV light, this bond basically breaks down. Okay, and what happens to that is that the electron that was given by this bromine is taken by this bromine, and the electron that was given by this bromine is taken by this bromine. And this basically leads to the formation of a species that what we refer to as free radicals. Now, what basically are these free radicals? They are basically species that have this lone pair, that have an unpaired electron, not a pair. Okay, it basically has an unpaired electron, and this is basically what we refer to as free radicals. Okay, now one thing to note is that the arrows over here is half, which means that only one electron is going to this bromine. If the arrow was this, it meant that a pair of electron, right? But since only one of the electron is going to this bromine, this arrow is only halved. Okay, now this is one of an important thing that you have to understand. Okay, the arrow should be half and not full. Okay, and I guess you should basically know the name of the process, bond breaking process. Okay, this is basically homolytic fission. Homolytic fission. Now, this is the type of bond breaking in covalent bond where one of the electron goes to each of the atom involved in covalent bonding. Okay, so yeah, this was the initiation step to make. Okay, so the first step of a free radical substitution reaction would be the formation of these radicals. Okay, the formation of these radicals. Now it says that write two propagation steps to show that C6H13Br is formed. Kali arrows are not required. Okay. Now haloalkane. Okay. It means that uh, alkane reacted with a halogen led to the formation of this. Okay. Now what was the alkane? The alkane was hexane. CnH2n plus 2. Okay. It meant that C6H12 C6H14. Okay, this was the alkane. Okay, so the reaction would look something like this. Okay, these are the propagation step. First of all, you basically need to form these free radicals, and once these free radicals are formed, it would react with this alkane to form this haloalkane. Now how do I even remember this sort of steps? Okay, now see, I think this is free radical. Okay, it basically has one electron. It basically has one electron, but the thing is that it basically wants to gain a pair of electron. So what it would do, it would basically steal a hydrogen, okay, and form a bond, HBr. In this bond, a hydrogen would be giving one electron and a bromine would be giving its electron. Okay, hence bromine could achieve two electrons in this format. Okay, now this is basically a crude type of analogy that I keep in my mind while doing these questions, because this makes the question way more simplistic. Okay, now the thing is that another free radical of this would form. Now, why the free radical of this would form? Okay, now we could remember this as something like, suppose C6H14. Okay, now 1 2 3 1 2 3 1 2 3 1 2 3. Okay, and there are these three hydrogens. Okay, and suppose there's this hydrogen, which would mean that uh, carbon give its one electron and then hydrogen give its another electron. So what basically is happening over here is that whenever a bromine is here, this basically is bromine, right? Now this basically wants a electron. This is electron hungry. Okay, so it would ask the hydrogen to come and bond with it. Okay, hence it would basically obtain two electrons. Okay, so it would look something like this, H BR. Okay, so these basically are some crude analogies that I use to remember this process. Okay, because this free radical substitution can get complicated as per some of the students' opinion. Okay, so the hydrogen's electron would be here and the bromine's electron would be here. Okay, now there were initially two electrons over here, right? But hydrogen took its electron and bonded with bromine. So what are you now left with? So you're basically now left with only this, only one electron of carbon, because hydrogen have taken its electron and bonded with bromine. So you basically have been left with one electron, and this basically leads to the formation of this radical. Okay, Easy enough. So you basically keep in mind about this, okay, and try to remember this in this way, okay, so it would make life way more easier. Now comes the revenge kind of analogy. A radical of this is formed. However, it basically would want another electron since the electron of this was stolen by this bromine radical. So in the next step, what this is going to do is it again will take revenge from Br2. It again will take revenge from Br2. Since the bromine radical have stolen the hydrogen from this hexane, now the hexane is going to take a revenge on this bromine. So what basically it is going to do is that now bromine is bonded to another bromine, okay? So what basically it is going to do is that it will say this bromine, okay, since this bromine radical, you have taken my hydrogen, I'm going to now take one of the bromine, with one of the electron from you. And this is basically what happens, okay? So what this is now going to do is that this thing is going to stole it, okay, with its unpaired electron. And this thing is basically going to join with it. Now see, it basically has these two electrons, one from this and one from bromine. Okay. Now it is equal and everyone is happy since the revenge is complete. Okay. So this is how I used to remember this. Okay. And this is basically what happens. Hence, and hence the revenge is taken. Okay. The revenge is taken. First of all, bromine stole the hydrogen, and now this radical stole the bromine, revenge equal. And this is how the reaction is going to proceed. Okay, so yeah, since it's asked about two step, so this was it. This was an analogy. Okay, I hope you did understand everything about it. Okay, and if you still didn't, then do let me know in the comment section. I will make another video on this separately. Okay, moving on. Give the molecular formula of an alkane formed in the termination step. Now, what basically is the termination step? It is the step where two free radicals reacts together. This is the termination step, is the reaction step where two free radicals reacts together to form an something. What are the free radicals in this reaction? This is a free radical, right? So two free radicals of this will react together to form a molecule of this. Okay, C6H13 radical, C6H13 radical, 6,6,12, 13, 13, 26. This is basically the termination step. Termination step of a free radical substitution reaction is the step where two free radicals would react together to form a compound. Okay, clear? Moving on. Now, the two terms that I said over here are extremely crucial. I hope you remember this, right? Nucleophile, nucleus seeking, and can donate a pair of electron, lone pair of electron. Electrophile is electron seeking and can accept a pair of electron. Two really important terms to remember before we move forward, okay? Now, in this question, it says that ethene, an alkene, and chlorine reacts together to form this compound. Okay, draw the mechanism for the reaction between ethene and chlorine to form 1,2-dichloroethane. Okay, include curly arrows and relevant lone pair and dipole. Now, the type of reaction is what we refer to as electrophilic addition. Now, what basically is an electrophile? Electron seeking and can accept a pair of electron. Okay. So first of all, this is the electrophile. Okay. Now what basically happens over here is that the pi bond, okay? First one is sigma and the second one is pi in a double bond, right? The pi bonds are electron rich. electron rich, okay? The pi bonds are electron rich, okay? So there are electrons over here, right? And basically there are electrons over here as well. There are electrons over here and there are electrons over here. Now when the chlorine molecule tries to come closer to this double bond, tries to come closer to this, okay? Tries to come closer to this, okay? So what happens over here is that the electron that was here is repelled by this electron, and the electron moves further towards this chlorine, because electron is gonna repel another electron, okay? So this electron over here is gonna repel the electron that is over here, and as a result the electron slightly moves towards this chlorine. Since the electron slightly moves towards this chlorine, the chlorines attains a charge, partial charge. So this charge is gonna be delta plus, and this charge is gonna be delta minus, delta minus, okay? Why? Because the electron was pushed towards this chlorine, hence this overall negative partial charge. And since the electrons moved away from this chlorine, it attained an overall positive charge. And this basically is what we refer to as dipoles, partial charges, okay? Now what basically will happen over here is that this is positive, right? Now what it wants to do is it wants to balance that positive charge, balance that positive charge. What basically it wants to do is that it basically wants to balance this positive charge. Now how is it basically going to balance this positive charge? By gaining something that is negative. And what basically is negative in our chemistry syllabus? Electrons. So where is it gonna gain the electrons from these pi bonds, okay? From the pi bonds, because the pi bonds are extremely electron rich. Now I'm not gonna get into the details of this, okay? Why is it electron rich? But if you still do have queries about why is it electron rich or not, do let me know in the comment section. So the electron is going to be taken by this chlorine, and the electron that was over here is going to go to this chlorine, okay? And the bond is going to break between this. The bond is going to break. The electron would be accepted by this chlorine first of all, and then the bond is going to break, okay? The bond is going to break because this chlorine have already obtained its electron from this bond, from this pi bond. So it basically do not need to have these two electrons, okay? It basically do not need to have these two electrons because it basically already obtained two electrons from this pi bond. It basically obtained this two electron from this pi bond. So it basically is no longer in need of these electrons, okay? So the electron then moves on to this chlorine. Clear? Okay. Now, this chlorine joins with this carbon or this carbon. It doesn't really matter, okay? And basically, as the electron from one of the carbon was lost, okay, it means that one of the carbon is giving one electron and the carbon is giving another electron, okay? It means that one of the carbon is basically losing up its electron. Since one of the carbon is basically losing up its electron, it basically is going to lead to the formation of this type of compound that is what we refer to as carbocation, because the electron in that initial double bond was one from this and another from this, okay? Now, since all of the electron is being taken by this, since all of the electron has been taken by this, there basically is some sort of an electron deficiency generated, okay? And that is basically what we refer to as this carbocation intermediate. Now, this chlorine with the electrons from here, this chlorine with the electrons from here is going to act as the savior for this carbon. How? Because this chlorine is basically going to donate this electron towards this carbocation. This chlorine is basically going to donate the electron to this carbocation, okay? And that is basically what happens, because this thing needs to be neutral again. And if this has to be neutral, how is it going to get neutral? By gaining something that is negative. And this basically happens. So yeah, this basically happens. And as a result, this forms 1,2-dichloroethane. And this reaction is basically what we refer to as electrophilic addition. Cause this is an electrophile. Why is this an electrophile? Why is this an electrophile even? This is electron accepting. This is basically accepting the electron from this double bond. And hence this is an electrophile, electron seeking. Clear? Okay, moving on. Now, hydrogen bromide reacts with 3-bromopropene to form 1,2-dibromopropane as the major product. Okay. Form 1,2-dibromopropane as the major product. Complete the mechanism to show how this reaction, to show this reaction, include dipoles and lone pairs. Okay. Understood. Now, the case with this is a bit different. All of the halogens are electronegative. We all know this, right? The halogens are electronegative. So what basically happens over here is that one electron is given by this and the another electron is given by this. Since bromine is more electronegative, bromine is going to pull this bonding pair of electrons towards itself. Let me repeat. Since bromine is electronegative, bromine is going to pull this electron towards itself. Okay? So, as the electron is pulled towards bromine, this hydrogen attains a partial positive charge and this bromine attains a partial negative charge. Now again, the same thing is going to happen from above. Okay, this is positive. It needs to do something to become, it basically is being positive, right? However, it wants to balance this charge off. And how is it basically going to balance this charge off? By gaining something that is negative, right? Electron. So this basically is an electrophile, electron seeking, and these pi bonds are electron rich. Okay, so what basically happens over here is that this comes over here and this bond and this electron goes towards this because the bond needs to break because it has already balanced off this electron from the electron of this pi bond. Okay, now what happens over here is that a carbocation form. Now there's a slight bit of issue with it. Now how do I even know that hydrogen is going to join over here with this carbon or over with this carbon? Hydrogen could join with this carbon as well, right? Or hydrogen could join with this carbon. Now, how can I be so sure that hydrogen is going to join with which carbon? Now, check something. In this type of scenario, in this type of electrophilic addition, there is basically going to be something bit different. In this type of electrophilic addition, keep this analogy in your mind. Rich gets richer. Rich, rich gets richer. Now, around this carbon-carbon double bond, which bond has more hydrogen? Which carbon has more hydrogen? This, right? So the hydrogen from that electrophile is going to join over here. There's a reason behind it. This is what we refer to as Markov-Nikov's rule. I'm not sure about the spelling. Sorry for that. It's a Russian spelling, Markov-Nikov's rule. Okay, it says that The carbon that has more hydrogen, the hydrogen from the electrophile would join with this carbon. Now it basically leads to the formation of a carbocation intermediate. That is stable. What do I mean by this? First of all, see. This is a carbocation intermediate, as we have saw from our earlier part of the question. Okay. Now, this carbocation intermediate has how many carbons in the neighboring has how many carbons in the neighboring carbon? One carbon, two carbon. Since it has two carbon in its neighbor, this is what we refer to as secondary carbocation intermediate. Let me repeat. Since this carbocation has one carbon over here and another carbon over here, this is basically what we refer to as secondary carbocation intermediate. Okay, if this carbocation has only one carbon around it, this is primary. And if this carbocation had three carbon, one, two, three carbon around, this is tertiary. Now there is a thing known as stability. Tertiary primary carbocation is less stable than secondary which in turn is less stable than tertiary carbocation intermediate. Now why? This methyl group over here has an electron donating effect to this positive carbon, right? So this thing over here is plus. Now it basically needs to do something to decrease the it basically needs to do something to decrease the intensity of the positive charge, and this methyl group over here and this carbon over here is doing the same thing. It basically is having an electron donating effect. This methyl group is having an electron donating effect. It is basically shifting the electron density towards this carbon to decrease the intensity of the positive charge, and hence this is stable. Let me repeat. These alkyl groups are electron donating, okay, has an electron donating effect. It basically shifts their electron density towards this positive charge to decrease the intensity of it, and hence this is stable. So primary carbocation is less stable than secondary and less stable than tertiary. Hence, this hydrogen would join with the carbon around the carbon-carbon double bond that has more hydrogen joined to it, okay? To form what? A carbocation intermediate that is going to be stable. Now, this is plus, and our bromine, the great savior, is going to donate the electron to this carbocation. And yeah, the product forms over here. Okay. So take a look at this, and this is what we refer to as electrophilic addition. Moving on to the next question. Now, complete the mechanism for the reaction of potassium hydroxide with 1-chlorobutane to form butane 1-ol. Okay. Use curly arrows to show the relevant dipoles and lone pairs. Okay. So, as I said, halogens are more electronegative. Okay. So the carbon is donating one electron and chlorine another. But the electron would be more attracted, would be strongly attracted towards this chlorine because halogens are more electronegative than carbon, hydrogen, and so on. Okay. As a result, a partial charge would form delta minus, and this carbon would attain a charge of delta plus. Okay. Now, this is basically positive, and it basically needs to balance this charge by gaining something that is negative. And this is where our hydroxide comes into the show. Okay, the hydroxide comes into the show. Now the hydroxide has a lone pair, okay? Now, this is basically what I refer to as what? Any guess? Rough estimation? Nucleophiles. They are basically nucleus seeking, see? They are basically nucleus seeking. And they have a lone pair of electron which they could donate to this nucleus. This is a nucleophile. This is nucleus seeking. They could basically donate this lone pair of electron to the nucleus and balance the charge off, right? So basically this is going to happen over here as well. So this electron goes to this carbon, okay? And this bond then breaks because it has basically already gained this 2 electron from this hydroxide ion, okay? So it basically do not need to have this chlorine anymore. And as a result, this forms an alcohol and chloride, okay? Let's just show chloride forms. So yeah, this basically is the reaction, okay? As simple as it, okay? Now, okay, let me just tell you something. When a non-metal, when a non-metal, when a non-metal exceeds the bonding capacity, when a non-metal exceeds the bonding capacity, it forms plus. It forms plus. And when a metal exceeds bonding capacity, it forms minus. Now you have to remember this. Why? Because this question may arrive in another version. So what basically could be the other version of this question? Now let's just assume, let me just get some space, okay? Let's just assume that there's a compound like this. This is bromine and so on, okay? Now, as a result, this is going to be del plus, this is going to be del minus. Now, what about if we had a water? If we had a water, if we had water over here. Now, oxygen basically has lone pair of electrons. And as it has lone pair of electrons, it could basically act as a nucleophile as well. So what it could do is that it could donate this to this carbon. It could donate the lone pair to this carbon and the bond could then break, okay? Now, it would basically lead to the formation of this compound, 1, 2, and this is going to lead to the formation of this O, H, H, right? And plus Cl minus, okay? Now, the interesting part is that oxygen is in group what? Oxygen is in group 6. It has 6 electrons in the outer shell. It basically needs 2 more electrons to make this octet, okay? It has 6 electrons in the outer shell and it basically needs 2 more electrons to make this octet. To make this octet. But how many bonds did it form? 1, 2. So oxygen, as it needs 2 more electrons, it means that it basically needs to form 2 bonds. Now see, how many bonds are formed around oxygen? 1, 2, 3. And this is a non-metal and it exceeded its bonding capacity, right? So it would basically lead to the formation of something that is plus. Now to neutralize this, a hydrogen would give the electrons to this oxygen. Now to neutralize this positive charge, a hydrogen bonded to oxygen would now give the bonding pair of electron towards this oxygen. okay? Or you could say that oxygen is a bully and takes both of the electron towards this. And as a result, hydrogen forms. Hydrogen is left with H plus only. And since this has these electrons, it could then form a bonding with this hydrogen to form HCl. Okay. Now you may be uh, encountering this. Okay. So I have basically showed you this version of it as well. Okay. So yeah. Now the same mechanism is going to work for other nucleophiles as well, such as cyanide and so on, right? These are all nucleophiles, such as cyanide. Same mechanism, everything is going to be the same, okay? For other nucleophiles as well, cyanide and then NH3 and so on. And this reaction is what we refer to as nucleophilic substitution. Why? Because a nucleophile, when it joined with this, substituted something, made something go out of the bond. This is referred to as nucleophilic substitution. Now coming to the last type of mechanism that is explicitly mentioned in your syllabus is gonna be nucleophilic substitution of NH3. Now again, let's start electronegative del minus del plus. Now nitrogen has a lone pair of electron in its outer shell. Okay, nitrogen has a lone pair of electron in its outer shell. Why? Nitrogen is in group what? Group 5, right? 5 electrons. So in 1, 2, 3, 4, 5, 6. Because hydrogen can gain electron, right? So 1, 2, 3. It means that it has a surplus of 2 electrons. Okay, hence, as it can donate this pair of electron to a nucleus, this is what we refer to as nucleophile. So what would happen over here is that this is going to go from here to this, and the bond is going to break. Okay, and the bond is going to break. Now, this is a non-metal. It could form a maximum of what bonds? 3 bonds. Okay, since it is in group 5, it means it has 5 electrons in the outer shell. So it basically needs to gain 3 more electrons to form an octet. Okay, 5, 6, 7, 8. 5 plus 3 equals to 8 electrons. Okay, so it basically needs to gain 3 electrons to form an octet. So it means that it basically needs to form 3 bonds. Now let's just see how many bonds did it form. 1, 2, 3, 4. It exceeded its bonding capacity, right? So what basically it is going to do is that it basically is going to form this plus thing. Now to balance this off, this bonding pair of electrons would be going to this nitrogen. Okay, you could say nitrogen is a bully and would take the electron that the hydrogen one of the electron was given by hydrogen and the another was by nitrogen, right? Now to balance this charge of plus charge of, the nitrogen is going to take both of the electron towards itself. Okay, since this is the bully, right? Now this thing is going to form H plus. Okay, this thing is going to form H plus. It means that it basically also needs electrons to balance of the charge. Okay, it basically also needs electrons to balance of the charge. So what basically is going to happen over here is that this nitrogen also has lone pair, and this nitrogen is going to donate the lone pair to this hydrogen. Why? Because as the electron from over here is taken by this nitrogen to balance of this positive charge, H plus forms. Now H plus basically needs to gain what? Electrons to balance this positive charge off. Okay, now an important part. Since this thing is accepting a proton, this is technically H plus after this both electron goes to this nitrogen, right? Since this thing is basically accepting a proton, H plus, what do we call proton acceptors in chemistry? Base. So this reaction over here is acid-base reaction. Something that accepts a proton, H plus, is what we refer to as base, okay? And it basically leads to the formation of this compound, amines, and this NH4 plus. I hope you all are clear with it, okay? So we have done this. Let me just tick this off. We have done this substitution. We have done this explicitly for hydrogen bromide and for bromine. Hydrogen bromide, just a minute. Bromine and hydrogen bromide to ethene and hydrogen bromide to propene, 3-carbon compound. We have done this. We have also looked at the stabilities as well. Now we have done it with OH minus, NH3, and I have also showed you the one for CN minus and the another for H2 as well. So that concludes the crash course on the mechanism for these questions. If you found our video to be helpful, then make sure to like, comment, and subscribe. All the best for your upcoming exams, everyone. Have a great day.